Okay, lesson 3.5. We are solving equations. Now, I kind of set this up as two different sides. On the first side, we are focusing more on using our log properties. Okay? So it's more about using our log properties on the front side. On the back side, it's going to be more about, okay, the bases are these are exponential problems. The bases aren't the same. How do we solve? Okay, we can't make the bases the same. So I've kind of got two different things going. I'm not saying I don't think we're going to do all 12 examples because it's going to get to be a lot, but we're going to do some on the front, some on the back. Okay? So, you guys know when it comes to solving equations, these steps are kind of a guideline. Okay, I wrote steps. I should have probably just said guidelines. But if both sides have logarithms, we're going to start by writing each side as one logarithm. Okay, so and some of this will depend on each problem. But so if you have a problem that is logs on both sides, get it so it's one log equaling one other log. Okay, once that is, if they have the same base, you can just set the insides equal to each other and solve. Okay, we might also have to think about our change of base formula. We might have to think about left, right, middle, depending if there's only a log on each side. So it's really just taking all of our log knowledge and making it work. Okay? So, as we look at A, log base b of 5 plus log base b of 4 minus log base b of 2 equals log base b of x. Okay. Based on what I just said, what am I going to suggest?
Condense.
Condense, right? We have 3 logs on the left. I know 3 logs did not go well Friday in notes, but this one's not bad. It's not ugly. What do you know about log base b of 5 plus log base b of 4 minus log base b of 2?
Log base b of 7, right?
No.
Just kidding.
Log base 5 times 4 divided by 2.
So it's 10.
So I'm going to write it out as log base b. So 2 logs being added can be rewritten as 1 log where the insides are multiplied. When you throw in a subtraction there, it can be rewritten as a log being divided. So I didn't jump to when we say it was going to be 10. I didn't jump to there, but you see where that's going, right? So 2 logs being added shows multiplication. The log being subtracted shows as division. If we clean that up, log base b of 10 is equal to log base b of x. What do you know?
X is 10.
X is 10. Both sides are log base b. Since both sides are log base b, then we know that x is 10. Okay. I don't know that it'll happen a whole lot, but be in the habit of at least, I'm going to say checking your answer. Just kind of glancing at it and does it make sense? Is that a good way to put it? In other words, is a positive 10 a possible answer for this? Yes, because 10 is positive, we can have log of 10. That does make sense. Okay? Did it matter that we didn't know the base? No, not in this particular problem. Okay? Most of the time you'll be given a base, so that won't be an issue. But just something to be aware of there. And I will say there are a lot of different variations of how these examples can go. So, okay. Ready for B? 2 times log base 5 of x equals 1/2 log base 5 of 144 minus log base 5 of 3. Thoughts of where to go?
The first one can be log base 5x squared.
Okay. Can we use our power property? Move that second to the power, so log base 5 of x squared. What about the right side?
The first one would be log base 5, 144 times, or like with the exponent.
Yeah. And here's the deal. You have to move that 1/2 to the power before you can think about dealing with the subtraction. Okay? You can't use your product or quotient rule when there are values out front. Now, so log base 5 of 144 to the 1/2 minus log base 5 of 3. What do you know there?
144 would be 12 because it's the same as saying 144, like the square root of 1.
Yeah. Something raised to the 1/2 power. So side note here, 144 to the 1/2 is the same as saying square root of 144, yes? And we know the square root of 144 is 12. So this is log base 5 of x squared equals log base 5 of 12 minus log base 5 of 3. And you can clean up some of these steps. You don't have to write all these steps that I'm writing, but okay. Now what?
12 divided by 3.
Log of 12 minus log of 3. 2 logs being subtracted can be rewritten as 1 log where the insides are divided. And because I don't want it to risk losing anybody, yes, I'm taking the extra step, okay? 12 divided by 3, which if you wanted to, you probably just went ahead and wrote log base 5 of 4, didn't you? And that's fine. What do you know?
Would x equal 2?
Kind of.
Positive or negative 2?
Positive.
Okay,
Oh,
so log base 5, they're the same, yes. Since logs are the same, they're the same bases, we can rewrite this equation as x squared equals 4. Okay, so I didn't want to jump to just x equals 2 because I want to be able to talk about this. So officially it's x squared equals 4, but you guys know what are we going to do? Take square root, and so then it becomes officially x equals plus or minus 2 officially, yes? Okay. What do we know? Does this negative work?
No.
And this is where it all depends on what the original problem was. Where did x go in the very original problem? X went there, right there, yes? And that would be saying the log of negative 2. Okay? Because that 2 isn't there as a power yet. So officially, we cannot use the negative, and so we just need to say that our answer is x equals 2. Okay? Now, should you automatically assume no negative answers today? No, because it all depends on what was the original problem. In this case, it was log of x. But if this had been log of x plus 5, well then negative 2 plus 5 is 3, and that's still a positive value. So it could still work. This is why we beware and just kind of check.
Does it not count as technically that x is being, like, taking the square of, and that would equal a positive?
But it's not written like that in the original form.
Okay.
Okay. So. Okay. Shall we try C? Log base 4 of x plus 6 plus log base 4 of x equals 2. What do you know?
The log base 4 x times
2 logs being added can be rewritten as 1 log where the insides are multiplied. So log base, that's a weird 4. Log base 4 of, and it's x plus 6 times x equals 2. We said to multiply them. What is x plus 6 times x?
x squared plus 6x.
Okay. And again, some of you may have jumped to that. So this is log base 4 of x squared plus 6x when you distribute that x equals 2. Thoughts of where to go next?
subtract 2.
What's your plan after you subtract the 2 over?
Boil the x squared plus 6x.
But it's not just x squared plus 6x, it's log of x squared plus 6x.
Would you break up the x squared plus 6x to x plus 3x plus 2?
No, because there's not a constant there.
Is there any dividing? Am I wrong?
Not in the way I'm taking us.
Alright.
And I will say, I feel like a lot of these log problems, there's multiple different directions of where you can go to get to the final answer, which is why I hesitated. I'm not just automatically going to say no. I'm going to kind of listen.
Alright.
What's different about this problem compared to the last two?
There's no log in
It's not a log on both sides, is there? There's just a log on one side. And so that makes the difference. We can't just say, oh, inside equals inside and go from there. How do we get out of log form and into a different form?
it would be log of x squared plus 6x. No.
Natural.
What?
The element, right?
I don't think I want to go change of base.
Just kidding.
Okay. Would it be left, right, middle?
That's where I would go with this. When I have a log on one side. Now, it'd be different if I didn't have this, maybe change of base. I'm not going to rule out change of base formula, but because it's still x squared plus 6x, it wouldn't get me very far. And so with that in mind, I would suggest a left, right, middle. So left, right, middle says what? The left is 4 raised to the right of 2 equals the middle of x squared plus 6x. Okay. What do you know?
16.
4 squared is 16, so 16 equals x squared plus 6x.
And then would you subtract over the 16 and factor?
Yep. Because I got rid of the logs, it's just a traditional equation. I am ready to make my equation equal to 0 and see what I can do with it. So 0 equals x squared plus 6x minus 16.
There's so much easier.
Positive 8 and negative 2.
X plus 8, x minus 2. Officially set each factor equal to 0.
It can be negative, right?
What solutions do I get officially?
Negative,
Negative 8 and positive 2.
Negative 8 and positive 2. And here's what I'm going to say, is go back and check.
Wait, what am I checking for to see if it can be negative?
Okay, so the inside of a log cannot be negative. So in this case, would either of my answers make x plus 6 negative or x negative? Right there, since it's log of x, this negative 8 can't work. Could the negative 8 have worked here?
Yeah.
It wouldn't even work there either because negative 8 plus 6 is negative 2, still a negative. Okay, does 2 work? 2 plus 6 is a positive, 2 is a positive, 2 is good. Okay? So, that's the reason. Be checking, be careful. Okay. Let's look at D. Okay. Sorry, I have D worked out 2 different ways, so I'm looking at my options. What are your thoughts here?
Do we start by dividing the 3?
As in 2 logs being subtracted, can be rewritten as 1 log where there's division. That is an option. And probably the option that would be more obvious. So this left can be rewritten as the log of base 9 of 5x minus 2 divided by 3 equals log base 9 of 2x plus 1. Now what?
Could you multiply each side by 3 to get rid of the denominator?
Not yet.
Left, right, middle. No, because you have log base 9 on the other side.
If I have log base 9 on both sides,
You can drop
we can drop the log base 9s, and the inside has to equal the inside. Okay? As in, 5x minus 2 over 3 should equal 2x plus 1.
Oh, now
Now I'm willing to discuss multiplying by 3. Okay, that 3 was still inside of a log, which is why I said not yet. Okay, easiest way to solve this at this point would be to get rid of that denominator because it's kind of ugly, isn't it? So if this is dividing by 3, we want to multiply by 3. If we multiply the left by 3, we're multiplying the right by 3. What happens on the left? 3 cancels and you're left with 5x minus 2. What happens on the right? What'd you say? I think you had it.
6x plus.
Yeah, can you go ahead and distribute that 3? You have to sometime, now or later, so 6x plus 3. Now what?
Subtract over the 5x and subtract over
Okay. This is just x's and numbers, isn't it? There's no squares, there's nothing fancy. So Katie's having us subtract 5x, move your x's to the right, which means I'm subtracting 3 to move our constants to the left. And let's see, 5x minus 5x cancels. Negative 2 minus 3 is negative 5. 6x minus 5x is x. 3 minus 3 cancels. So we end up with x equals negative 5. You need to check to see if it makes sense. Can it work? Yeah. If you plug negative 5 into that original, 5 times negative 5 is negative 25 minus 2. I just got log of a negative value. Okay? So I don't even check the other side. The other side I don't think works either. And so this is a no solution. Which way is she gonna write it up?
I try and guess every time.
No, I mean it doesn't work. Okay, so. Okay. Well, let's see. E or F here I'm baiting. Might have time for both. I don't know. Okay. Thoughts on E?
Move the 3 to the back.
Okay. Move it to a power. Okay. And here's what I'm going to go with. That's one option. Perfectly fine. Okay. I see two options here. So if we move that to the power, I now have log base 3 of 3x minus 2 minus log base 3 of 3 equals 2. Actually, I see a couple. I see more than two options here. Okay. Next option. Nope. Like, why is everyone staring at the screen so funny? I just deleted the 3 from the problem all the way around. Not sure why, but okay, is that better?
distribute the 3, or do you go ahead and rewrite it as division?
I'm not sure what 3 you would talk about distributing.
Like, do 3x. No, you wouldn't want to do
We don't want to multiply out 3x
that.
minus 2
That
to
was
the
a
third.
silly little thing. Would you do 3x minus 2 cubed over 3?
Okay. So one option is 2 logs being subtracted can be rewritten as 1 log being divided. That's an option. Let's go with it. So log base 3 of 3x minus 2 cubed divided by 3 still equals 2. And here's the deal. Could I maybe have to cube out that 3x minus 2 later? It could be. I'm just kind of holding out on it and hoping I don't. Okay, now what?
Left, right.
Okay. Left, right, middle? So left, right, middle. 3 raised to the second is equal to 3x minus 2 cubed all over 3.
You can do 3 squared, which is 9, and then multiply both sides by 3.
Yes. Okay. I'm with that. Can I go ahead and do that all at once here? I'm running out of room. Since this is division by 3, can we multiply by 3 and get it out of there?
No.
So on the left, I have 3 squared already, which is 9, times the 3, which is going to make this 27. Over here, the 3's will cancel, and I'm going to have 3x minus 2 cubed.
Oh, we can cube it. Oh my gosh.
Okay, so we are going to be able to avoid cubing that out because since it's parentheses raised to the 3rd power, we can take the cube root. If I take the cube root of one side, cube root of the other side. What is the cube root of 27?
3. 3.
Yeah, I was watching a discussion back there. Are we good?
Yes.
Okay.
Is
Okay. The cube root of 27 is 3. Is it plus or minus? I think that's what Kate was getting ready to ask. It's not plus or minus because it's not an even root. Cube roots, odd roots, there's just one answer. Okay? What's the cube root of 3x minus 2 cubed? 3x minus 2. Solve from there. What do we got? Add 2. 3x equals 5, and so x is 5/3. Okay. And this is where I just kind of say, do a basic check, right? 3x minus 2, if I do 3 times 5/3 and subtract 2, is that still going to be positive? It is. I don't have to have values or anything, but it is going to be positive. Okay. Am I out of time? Yeah, pretty much. I will say F, you get an answer of 8 over 125. Okay. It's a fraction. It's doable. We will pick up tomorrow and do at least some of the examples on the back. I don't remember exactly how the homework's broken up, but pieces with logs in them, could you start working those? You can start trying those if you want. Ones that are exponents, like what you see on the back, you can't really do those yet. Okay?